儿啊，你说的这些个苦楚，做爹的怎会不知？可大王一日不出谷底，你我就得再熬一日，熬住了才有活命。
想买货真价实的高货翡翠原料，奈何市面上的翡翠原料价格不仅高，且切斩好料难求，自己去缅甸买货不划算。在这里，我们10多年来在缅甸的乌兹河沿岸各大场口收料看料，从不错过每一次拿料的机会，把握原石出厂的一手货源信息。高货原料每日更新不断，高货、奇货、市面罕见的清纯翡翠原料，我们都有现场直播收料讲解，教你怎么辨别高货原石，怎么识别假翡翠，带你看真实的翡翠原料直播。
是可怜你那兄弟。什么味道？
And we actually optimized so much to the point where you could get the same level of recovery in 6 hours as you would get with a speed.
那下次给你给你。
轻轻地当路马路，静静不令狼伤，谁叫我身手不凡，谁让我爱恨最大，我是白头。 乱心后，是流成流干，结婚结婚结婚，是爱是或许心有梦，要一人风一光。 对，为是上司，是这渐渐，是三日三夜难懂啊。 佳节，情在这难忘。
破雷后，可怜那书归后就地负责。也见得夫死之亡有收拾离处。老大我右手无头狂虚情。
This is new. Actually, I'm larger. Seventeen. This. Oh. Okay, it's not a slow fill, it's like excellent reach. come on.
Architecture tells the story of those that came before us. I can get an understanding of how people lived, what people felt was important, times that they were in, and that's why I love to travel to different places. To say San Antonio is unique is an understatement. It literally takes your breath away. My partner and I were designing our new home, and we decided to go to San Antonio because we really wanted to create something beyond what we would be able to find in our everyday surroundings. Therefore, going somewhere like San Antonio, where we've got Mexican influences, Texan influences, Spanish influences, we really felt as though it would be a place where we could really capture a lot of ideas and capture a great deal of inspiration. If you go along the riverwalk, you literally look to the left, you look to the right. There's so much detail. There's not just restaurants and shops, although there are, but there's also architectural pieces. There's statues, things that really bring the area alive. Arriving at the historic market square, we immediately notice all of the colors and the culture of Mexico coming through.
世人都晓神仙好，唯有功名忘不了。古今将相在何方？荒冢一堆草没了。
We're finally doing it. A lot of people have been reaching out for a long time asking me to do videos about disc golf. So today we're doing a video about disc golf. And this is great because disc golf is right at the center of a lot of things I love. You've got aerodynamics and physics and all that kind of stuff. You've also got just spending time outdoors with your friends doing fun stuff. And then today, the special thing we're going to talk about is manufacturing, how you actually manufacture a disc golf disc. So obviously the aerodynamics of the disc are important because when you drive from the tee box, you want to throw it as far as possible and as close to the basket as you can, but also the mechanical interaction of the disc with the chains on the basket, that's important too because you want the putter to fall down in the basket. Chad and Brad Richardson from MVP Disc Sports up in Michigan, they reached out and said, hey, we love what you do on Smart Every Day, and we want to sponsor a video or a series of videos on disc golf for Smarter Every Day. So today I'm extremely excited because MVP Disc Sports does this special overmold on their discs. And a lot of people in the disc golf community think that's really cool for multiple reasons we'll talk about later. But that is an interesting process, and we're going to learn about it as a part of the overall Smarter Everyday manufacturing series. We've learned about metal stamping, roboforming, some really cool processes used to create films, and this video is going to roll into that. We're going to learn a ton of stuff about injection molding, about robotics, about how to design a plant for efficiency. So let's go get Smarter Every Day in Marlette, Michigan, and let's learn how MVP Disc Sports manufactures disc golf discs. I flew up to the Detroit airport, which is always exciting. It's so good. I drove 90 minutes north of the airport. Summers in Michigan are absolutely beautiful. I pulled into a large manufacturing facility. This is the headquarters and factory for MVP Disc Sports.
No photos or videos allowed. This is going to be difficult.
I was led in by Shelly, and then we passed a putting green that employees use on breaks, and I was led through the headquarters and met Brad and Chad, the two brothers I told you about who started MVP back in 2009. These are people that had a vision. They started small, and they started building things up, and they're using the talent pool from all over the Detroit area that traditionally works with automotive engineering and manufacturing. They're all pulling together, and it's been a huge thing for the local community. New manufacturing jobs in rural America using new technologies. I would love to see this model replicated across all of America.
Yeah, I was just senior high school. You're just starting college. Yep.
It was just kind of more of like a hobby. So it was like college during the week. Then we would go home and pack orders, stamp discs.
Yeah, Brad and I did this, us two, for 5 years before we got our first employee, 4 or 5?
Yeah, well, 4 or 5 years doing everything.
Slinging discs.
They always say it's the biggest sport you've never heard of is kind of, the phrase we use. It's out there. There's 12,000 courses worldwide, and yeah, we sell a lot of discs.
So in disc golf, you throw the disc and it goes into a chain basket.
Yep.
And your thought was if I could rubberize the outside perimeter, that the chain basket would grab the disc.
We were playing one summer, and it had a traditional disc, and I had a large rubber band. I don't know why. I stretched that rubber band around the perimeter just for that grippy edge and, putting with the target. And the idea would be, maybe that could help, catch into the target better with the friction. And we figured, we can try making that. And so we did. That's what the first run ion is.
So the intention wasn't to have a gyroscopic effect.
Right.
It was to
increase the friction. Yeah, that's where the idea started.
Yeah.
Yep.
I started with the rubberized outside, but then you kind of found your way into the gyro.
Yeah. Just because those were too light, and we said, hey, we need to make it heavier. Found weight fillers, and we had to make a choice, put it in the center on the overmold, and that's when I clicked.
Year number 2 was we made a mid-range disc, which was more focused on the gyro technology.
If you throw a disc with no rotation, it just flips end over end. Ultimately, it's a gyroscopic aerofoil. Is really what it is. We break it down in simplest terms. So if you increase that angular momentum, you're increasing the stability.
So if I had to guess, I would say you've done a lot of research into how dense you can make that outer ring.
That's our job, pushing those limits to increase that. We're never stopping that. That is our entire goal, increase that MOI. And, of course, other things like increasing the grip and durability, other things, players look for, of course.
Okay, there's 2 main ways that they make discs here at MVP. So we'll put that right here so we can see the difference. Okay, so this is a heavier plastic, this red stuff here. This is a lighter weight plastic, right? Yep. And this is a solid mold, a solo mold, you call it?
Yeah, solo mold.
So whether it's a solo mold or an over mold, the manufacturing process is pretty similar. So what we're going to do is we have this roadmap here, and we're going to go through all the steps required to make a disc golf disc. And we need to give ourselves permission to jump around along the way because we're going to take some tangents. But let's dive in and start and looking at the materials that go into the process. So
this is the manufacturing warehouse.
okay.
So this is essentially where the raw plastics come in. Most of our plastics are made in America, which is great. There's some European grades as well, but the vast majority of it is American-made plastics.
Got it.
Clear plastic granules here.
It's rubbery. Like when I squeeze it, I can feel that it's giving way, like it's pliable.
Yep.
And then, is that a vacuum?
Yep. Vacuum line here.
Where's it going?
It goes to the drying system.
Which is, so you have all this built, like you built this with this in mind.
You want to automate your material handling.
So this is kind of like those Coke machines, the fountain drinks, and you've got all the material here, and it feeds up, goes to your dryer, and then gets fed in to your...
Plastics drying. That's a very crucial step prior to the injection molding. At least for this particular polyurethane. It's very hygroscopic. Hygroscopic.
Okay.
Meaning it absorbs moisture from the air. And that's for the injection molding process, that's bad. You want to remove the moisture.
So step one, we get it from the shipper, or from the supplier.
Plastic has moisture, it just naturally absorbs moisture.
So step two, we have to dry it.
Yes.
Okay, cool.
Very important.
So those lines coming from the Gaylor, those have plastic in them.
Yep. Those feed the plastic to the dryer system.
What?
And they go here.
Did you design this?
We work with a company that helps us fit it to our specs.
Is it all stainless steel?
That's aluminum, but the elbows are stainless steel.
Okay.
The elbows have to be a tougher material because as that material makes that turn, there's a lot of friction. So as you see, they come down individual,
but you can see all the different grades of plastic granules inside each little hopper here.
The temperature and time at which you dry is important.
What is this?
This is our resin selection station. We can change these hoses, which changes which machine which plastic goes to. So instead of having, basically this is a central system.
This looks like a network patch panel.
Yeah.
This looks like you're taking Cat 5.
Yeah.
What's moving? Similar.
What's moving here material? Which one is it?
That's probably going to the drying hopper.
I can't see.
Yeah. Okay, so the key is it allows us to switch which material. So for example, we have a soft version or a firm version. We can switch it and it goes to the machine automatically. Much easier than trying to redo a bunch of lines.
Okay, yeah. Wow. What a neat part. That's a manifold.
Yep.
So you're bringing the material in here.
It comes over and into these first, and then it goes out the bottom here into this to the machine.
These pipes here.
Oh, and then it goes to the machine.
This is right before it goes to the machine.
Okay, got it.
Based on how much we're consuming at any given time, how much of that material is being used, if we raise this, it will increase its drying time because it starts from the top, and as it's taken away from the bottom, gives you how much time it's exposed to the dryer. So that is our time.
It's almost like a grain bin.
Yes, exactly.
Yeah, it's a grain bin.
Yes.
So on the grain bin video, we talked about you put the beans in there, you blow from the bottom. Are you blowing air?
There's hot air
right there.
So right here.
吾有因胡旋视曹河，吾有因读诗感，吾有因声色恶冷，吾有因慈悲颠倒何故？吾有因沙眼离地，是曰生震波纹。 安于旧盆，藏战于手，巧辩为门。
don't have it on me yet.
吾有因头悬是曹河，吾有因四无师管何故？吾有因诸事王吾有因慈悲颠倒何故？吾有因杀眼离子。是曰：生正脱魂，堪于救命，常在于手，巧辩为门。
That's new. Check doctor. It's $1 ring.
这丸子好骗，我可算是弄到这宝贝了。咦，你咋还没走？你不会是想要回这宝贝吧？不害臊！你个狗！狗日的，真不识相！还要跟我使这身手！不会还想要宝？赖皮，不知羞。这样啊，我也不能白给你，过会儿再来拿0元来换。
你送来。 Awesome. Again.
妈了个巴子，咋又这么迟啊？东西放下，赶紧回去下崽。下回再说迟了，耽搁了大王练功的进度了。老子亲自把你的傻儿子洗干净，送出去。你老瓜孙没来，你这拐子脸的小和尚哪儿冒出来的？管他娘的，老子先尝两口。
铁骑士却无力，大手铁炮造虎旗，敲刀姐姐慌不比，时候死你不死你。
小施主筋骨清奇，正响应着铜头铁臂。
嗯？
不知死活！
Come on.
把酒，不妙，去给咱烧酒。哎呦，神清气爽，是你把咱叫，嘿嘿，不过咱现在都到卧虎寺内有肉吃，那可得去瞧瞧。吃饱喝足才好做事，肚肠空空可是没。你这瘦鬼身子也该多吃点儿。走走走，跟咱去卧虎寺。
我先走。
这些烂熟肉实之若孽不吞真，气死咱！哎，你想法子给咱找点好东西尝尝如何？老夫馋那必偶馋得紧，偶尔吃吃素也未尝不可。事情有了些，那黄金之国真与这。传说中，黄金之国是太阳西沉落海之地，那里的人们以鼠为尊。只是不知怎的，适才咱尝了尝那些鼠精鼠怪，咂摸着像是还带点人味儿。那古国移民并未尽亡，黄风怪于古国的来之前。那个，时候到了。 适才咱尝了尝那些熟酒。那古国一米来之前，时候到了，咱这就回老地方试上一试。
Oh, spot.
Yeah, that's air?
That's going into, it's just like a grain bin, exactly like it. Yeah, right over here. Yeah. This system here.
So that's
a dryer. Yep. It's blowing the hot air through each system.
And it's going back to it. So it's a closed loop.
Yes. Yeah.
Got it.
Yeah. See that level sensor? That level sensor is our demand. So as a machine consumes plastic, if it gets below that level sensor, it will fire that demand to bring more material.
So where's the master controller for this whole setup? I love how they both know the whole system.
That's the master controller right there. Press 1, loader 1. Press 1, loader 2. There's different device IDs. Press 15, loader 1.
Dominic is MVP's process expert on injection molding. He's going to show us where that material first starts to be melted. So when you put the TPU beads in here, are you heating it up, or is this a screw auger type heating method?
This is a reciprocating friction. Yes, friction shear heat. Now we have barrel heats on this, but most of the heat that melts the plastic is created by the screw pushing the plastic into the barrel itself. These heaters on there are just to maintain that minimum level of heat. So things like your screw RPMs, your back pressure, how fast you're filling, those are all going to affect your shear heat of the plastic and the temperature of your melt.
Chad took me over to another machine to show me the screw outside of the machine. This is very similar to the thing I saw at Kodak.
Yes.
Yeah, they have
a very much smaller scale than the one at Kodak.
Yeah. So plastic pellets go here. It turns this way.
Yep. It turns this way and it feeds the plastic forward. And as it moves forward up the screw, the diameter between the flights increases. That pushes the plastic pellets against the walls of the barrel, and that's where that friction kicks in and melts our pellets.
This right here is a smaller diameter compared to out here.
I see.
That's where your shear is happening.
But is the outside of the helix the same diameter?
Yeah, outside of the outer is the same, and that fits in this diameter here. 50 millimeter.
50 millimeter?
Yep.
All right, so plastic goes in there, which feeds into about right here.
Yep.
It's turning. As it's turning, it's pushing the plastic forward. That shear and mixing creates a melting. Is this heated as well?
No, the screw is not heated, just the barrel.
Okay, the barrel's heated. So the process is called injection molding. That implies that this auger is injecting the plastic into a mold, and we're about to see one of those molds for the first time, and they're really cool. And the cool thing about the product today, you remember we were talking about the core mold that they make, and then they put the over mold on the outside. Well, the product they're running today is glow in the dark, which is awesome. Look at that. You can see which one has the over mold on it, which means the raw materials have to be glow in the dark. Isn't that cool? Let's go make some discs.
So these machines are our core machines. We'll get to one that's running. So the core, again, is the center portion.
So this is the injection mold, right?
Yep.
The mold itself is a large piece of metal. You have two faces, and we have this picker here that it's a Cartesian type thing. So we have a cavity in there, and we're injecting plastic, right?
Correct.
Okay. And And how long does it take for the plastic to flow in?
On this process, just over 5 seconds for the plastic to fill the cavity. After that, there's about 30 seconds worth of cooling in the mold. That will set the plastic up enough for it to be able to demold and for the part maker to grab it.
And so are you flowing water through the metal part of the mold to cool it down?
Yes, we are.
Okay. Is it chilled water or just room temperature water?
It is chilled water for this application. If you look on the bottom, we have 2 water circuits on each half.
Yep.
Cool water goes in and the warmer water comes out. We regulate the flow on that, so we have a turbulent flow.
Yep. Better heat exchange, just like a rocket nozzle.
Exactly.
So this is the rare case where laminar flow is not as awesome as turbulent flow.
Exactly.
I can see this. So now we're going to talk to Sean. Sean's got a mold, and he's going to break it apart and show us the insides. They're a little bit heavy, but... So this is an insert mold.
Yep.
So the insert would go there.
Yep. And the plastic would inject throughout here.
On the sides.
Yep. It comes in, whatever profile we put in, it fills in from the side here, get our perimeter. Then when it's done, it opens up, and these pins push the disc out.
Sean took me over to see what they call the flight plates. These are the actual inserts that go into that larger mold assembly.
Oh wow, these are all your inserts? These are all of our overmold inserts. So some halves match up with other numbers, but most of the time it's just an A side and a B side. So you'll get the top flight plate.
Yep.
Where you get the plastic coming in. Then you'll have a bottom flight plate, where your ejectors come out.
Wow.
Like I was.
前慢走，前慢走，再走怕你也无头。
甭急，甭急。哎呀，好灵，好灵啊！亏得我一直存着，算是找着正主了。
我是有莫强求，方便法门会解除。旁人以为稀罕我，做到旁门不入了。
你呀，这儿的妖怪被你打跑了。为寻这雕鼠偷来的丹炉，差点把命送了。道祖慈悲，好汉福寿无量。救命之恩无以为报，这个便送与好汉吧。察天地动静之机，探日月盈虚之妙，当可成矣。天地万物皆炉鼎，唯有上品得我心。内炼成丹，外炼成法。 们若有丹药之需，可随时来我这里。
Oh wait, I can go back up from here.
“分散逐风转，此已非常深。” 当年泾河龙王违抗天命，玉帝震怒，欲行连坐之罪，吓得那四毒龙神躲藏了起来。神仙又有何意？只要染了因果，不过都是盘。江河怀起，四毒龙神生死已定。当年泾河龙王违抗天命。 玉帝震怒，欲行连坐，吓得那四毒龙神仙只要染了江河怀起。 我这儿可都是稀罕玩意儿，要不是你来，我还不卖嘞。又是赔钱买卖，你可赚大喽！又是赔钱买卖，你可赚大喽！你再多带些灵玉。
猴子，我在这里。拨浪鼓摇一摇。你见过爹爹了？爹爹哪里去了？好可怕！大家围着我，他们都说是爹爹把村子里的人带去给妖怪吃了。骗我！我才不信！
Oh, you really can kill them all first.
猴子，我在这里。拨浪鼓，摇一摇。爹爹说，风沙散了，病就能好。哎，一看你就是外乡人，别皱着眉头。这
It's about relative security.
诶，好厉害！你怎么知道我在这里？这个地方只有我和爹爹知道，嘻嘻。偷偷告诉你，有个帮我治病的好朋友，就住在下面。唉，好久没来，也不知他自个儿的伤养好了没有。你也一起下来玩呀？
Funny.
“勾心剑状，还敢顶虎先锋名号，接着做那黄风怪的手下？哼！兄弟又如何？老子早晚要报这个仇！”那小孩的爹逃了，正愁没人送吃的来。
Okay, that can be good. I don't think I got room to install them.
如此甚好，与咱同赴古国如何？今人不见古时月，今月曾经照古人。你看，黄金之国也好，落日之国也罢，都已不复存在。传说这里的茫茫沙海之中，曾蛰伏着一只上古巨虫。这巨虫平日里沉睡地底，无踪可寻。一旦醒了，便会钻出来吞噬人畜。 偏偏它外壳坚若磐石，寻常刀斧弓弩难以穿透，往来商旅不敢靠近，周边小国更是苦不堪言。适逢一只黄毛雕鼠下界，途经此地，感应到那巨虫身上似有无上佛力，于是施法镇住巨虫，收为己用。小国国王大喜，将鼠妖奉为护国神圣，更为他建庙塑像，世代供奉。鼠妖图修炼方便，干脆留了下来。后来，鼠妖神功出城，掳走了唐僧，与孙悟空激战于黄风岭，已是风沙蔽日，日月无光。那鼠妖的神风着实厉害，若非灵吉菩萨出手，怕是真经难取。只是没了鼠妖坐镇，古国自是难逃覆灭的劫数。而原本水秀山清的黄风岭，也变成了今天这般模样。
I was saying, this profile is usually out here a little bit, so you never see those ejectors. Chad gave me access to his 3D CAD files for the overmold so I could animate what's going on with the injection molding process. The plastic pellets are fed from the hopper down into the screw, which uses friction and shear to melt the plastic. Now remember, this is a reciprocating screw, which means it has the ability to retract and push the molten plastic forward. Notice this yellow check ring is moving. On the backstroke, the auger turns and loads the syringe, so to speak, by pushing plastic through the holes that are under the check ring. When the screw moves forward, however, the check ring moves back, and it closes off the holes, and the plastic is injected into the mold under extremely high pressure. Inside the mold, there's what's called a hot manifold. And a manifold is a pipe that branches into other pipes. The plastic in this manifold stays liquid because it's electrically heated. Let's remove that liquid so we can see how the plastic is flowing into the mold. When the screw pushes forward, it pushes the plastic into the manifold, and then it splits and flows to both sides of the mold cavity as it fills it. The air in that cavity escapes through specially cut vents that are in the mold. Water is flowing through the mold body on the backside of the plates, drawing out the heat and solidifying the part. The amount of time it takes the part to cool down and solidify is called the dwell time. The mold opens and the ejector pins then kick out the disc. So this next part does a lot. We're going to take the cores and we're going to go all the way through the overmolding process, and it involves robots, and it's amazing because Chad designed these robot cells that just move the discs all the way through the process. There's lasers. You're going to love this part.
This is protected with light curtains, floor as well as the walls. This is where the operator can load up stacks of cores.
再往前，小命不保。不识祈祷，拿你这凡夫给大王做个人。
once it runs through 1, 2, 3, 4, then rotates. That way we can shuffle our colors. In this case, they're all uniform, but a lot of times if it's not glow in the dark, all traditional colors, they're all different colors. Before this cell, someone's job was to shuffle all the colors. There you go.
What's it doing there?
It's rotate. This is so we can go 1, 2, 3, 4.
So that's shuffling.
So we can shuffle 8 colors.
Wow, that's neat.
Yeah.
And you just keep it shuffling the whole time. So the robot.
不忍见此地百姓受苦受难，出手降妖。只是那妖怪道行不浅，大王就在前面。实不相瞒，我洞中还有未成人的2个孩子，不能在此送了性命。
Come grab a disc. That's a pretty wild end effector there.
Oh yeah.
Did you design the end effector?
I did not. I partnered with.
Did it spray something on there?
The disc want a suction cup together. There's a small pneumatic cylinder that is knocking the disc below it in case it was suction cup. It doesn't always suction cup, but it just fires no matter what.
That looks like something you added on afterwards.
It absolutely was. Yeah.
Okay, that makes sense.
Yep.
All right.
The disc below it in case it was suction cup. It doesn't always suction cup, but it just fires no matter what.
That looks like something you added on afterwards.
The disc want a suction cup together.
That's a pretty wild end effector there.
Oh yeah.
Did you design the end effector?
I did not. I partnered with.
Did it spray something on there?
The disc want a suction cup together. There's a small pneumatic cylinder that is knocking the disc below it in case it was suction cup. It doesn't always suction cup, but it just fires no matter what.
That looks like something you added on afterwards.
It absolutely was. Yeah.
Okay, that makes sense.
Yep.
All right. All right.
After I picked it up, you can get a better angle here.
Yep.
It goes to that jig.
Yeah. It looks like you're setting it in there and you're indexing for a position.
Correct.
Yep. So it indexes in such a way where it always knows where the center of the disc is.
Yeah. And with our different diameters, we have offsets on our control panel that we can select to accommodate the different diameters where those offsets are.
So it's waiting on the last one to shoot. It's going to go take out the shot, and it's going to put another one in. So it's unloading and loading at the same time. So you don't eject until the robot is in position.
Yes, it wants to be a catch.
After we come out of the protected area here, so we're going to, this is the overmold.
Yep, this is your sprue, where it's coming from your sprue to a runner to your gate where it's interfacing with the cavity, and then also our added trim groove feature, which is not traditional.
So we got to trim that thing off.
Yeah. Yep.
Yeah.
So this makes a cutting condition. Oh, this is our transfer jig for the collaborative robot pick up from.
What do you call this machine?
This is our flash trimmer. It trims that outer perimeter, trimming the gates as well as that feature we put on there, that groove. Yeah, I call it flash trimmer, but it's more of a groove cutter.
Is that a razor blade?
Yeah, that is a ceramic blade. We move the blade up and down to extend the life.
Oh, I see. You actually move it vertically.
Yep.
Oh, and you have just a little micrometer.
Yep.
Adjustment here.
And you can see we have a vacuum cup that lifts that part up. We lift that up so we don't have to make a double entry with that robot. The robot can go in, drop, lift up, and grab it all in one entry. We tried to make it so you can remove and then come back. It's all one entry. Drop. Okay.
So this is a proximity sensors everywhere.
Yep. Part detection is key for automation. Robots are blind, so you got to tell it where the parts are at any given time.
Part detection.
So in this case, this transfer stand, so it's going to wait at the end of a cycle. It's looking for that press sensor to be triggered when that part falls. So that robot's waiting, and it's going to meet it. That little wiggle is an intentional get things to settle, because every once in a while, see, this interface is gravity fed. Well, the problem is when it locates on those two pegs, our two runners sometimes can be indexed a little funny, where it can intercept the end of arm on the cobot. So we do a little bit of that wiggle motion to make sure it settles in between those grippers. Oh, I saw it. I saw it actually rotated a little bit. Yep. And that lines it up here for the trimmer as well. This is probably the most pleasing part of the process. Yeah. All the hard work you'll feel when you see it move.
想必你有几分神通。那妖怪身上不知有
Oh, I saw it. I saw it actually rotated a little bit. Yep. And that lines it up here for the trimmer as well. This is probably the most pleasing part of the process. Yeah. All the hard work you'll feel when you see it move. All right, and obviously, all of this. Yep, yeah, you can pull it up. This is going to go to regrind. Yep, we make R2 discs out of it. You make what? Recycled. Our recycled line is called R2.
R2 Neutron is the recycled process. So any waste material that comes out of here, we felt it was better to make a product out of it than have to send it to the landfill. So it's kind of part of our mission of sustainability of being able to use everything.
So you call this a cobot? Yeah, cobot, collaborative robot. Yep. These have opened up a lot of doors. The main advantage is you don't have to have any gardening. Now, I say any gardening. You have to be careful on how you use these. Everyone thinks you can buy them and just, zip them around everywhere. There's a speed.
雷谷之法本是这天尽头的百姓为抵御太阳西沉入海的海废之声而发明。海水沸腾，声音之大，可以震杀城中小儿。雷谷之法解了此难，却又引来了妖怪。他有法宝护身，无可奈何。你既有胆来，恳请助我。 我来助你。赢。不想他这把大招，真是带累了你。休要不待，动起手来！
Limits and also a height limit. You can't go above, shoulder. You don't want to be in your neck and eye area.
That's what this is for. Is this an OSHA thing?
Yes, yeah, this is OSHA thing. But in general, what this is, every axis. On this has force sensing. So if it were to bump into you or get you pinched, it will stop and won't cause bodily harm.
That's what's different about this yellow one here.
The yellow one will just eat you up. This will be bad.
It's like getting hit by a car.
You can see our sign on the window to give you an idea. Yeah.
Velociraptor containment, yeah.
So that's why there's not a case. So if I were to bump that, it would stop. Yep. After trimming, it's going to swing over to that laser.
What does the laser do?
So that laser, underneath the laser is a scale. That scale is communicating with our...
Oh. Wait, 红之后。
Controller, and that controller is communicating with the laser, and it's going to mark the weight in grams on the disc.
Oh, so it's it's burning.
Yeah. It's a controller, and that controller is communicating with the laser, and it's going to mark the weight in grams on the disc.
Oh, so it's it's burning.
Yeah.
It's burning it on there.
Yeah.
So it actually uses the laser to burn that on. These have kind of changed. So are you feeding colors into?
Yes, with our feeder on the other side of the machine.
Yeah.
Here's our color recipe master.
You do the colors?
Yes, I do the programming of the recipes on the color feeders. We're using this color feeder right now to try to make a nice swirly overmold on all the parts.
These you feed in. Where are you programming this at?
The program all gets run in right here. We can do it on a PC as well and then transfer it onto here. But this, most of the time, we'll just build the recipes in here. Normally, when you're running through your color program, you want to just kind of follow the rainbow. All the colors that
Ooh.
Each other in the rainbow, they all get along very well. So as long as you start, you know, with your reds and work your way through.
That makes me want to see like the Wall of Shame where you make a bunch of dumpy colors.
It does happen. The colors that don't get along when they mix together look awesome when they're side by side.
I see.
So like a red and a green, you don't want to mix, but if you can get red and green next to each other without mixing, it looks phenomenal.
So they're complementary colors.
Exactly.
They're across from each other on the color wheel.
Yep.
There's two different feeders. There's auger style or cylinder. This is actually a full cylinder rotating.
So it's not much at all.
No, it takes very little.
So it goes into this Plinko style merge
There's
machine.
some magnets there to capture any metal or ferrous material. Sometimes you get metal shavings.
Goes in there.
And then a vacuum. This is a line vac. It's a Venturi vacuum that goes through.
And that goes all the way up here and feeds into the funnel. So now that we have the disc made, it's time to put the art on the disc. Now, this is kind of a thing because it's how the athlete emotionally connects with the disc. Like, oh, for example, I went putting the other day. I knew the Gyropalooza was going to do what I wanted to do, and I got to call it the Gyropalooza. Well, that's a festival they do. Anyway, the art is a thing, and people love the art on their disc golf discs. So we met up with Manuel, who showed us how to put a single color graphic on a disc. So this is just a normal disc.
Yep.
And then what is this stuff right here?
This is your foil, so that's going to put the lab second print on there. So it varies in colors that you can do foils, but for this you want to just do black. And the safety here, so you can't just do it one-handed, so you can't get anything injuring you. So you just do two here. Comes down, take it out, make sure it's good and looks really good.
Oh, it's advancing, yeah. Is it heat?
And a switch.
Yeah, it's heated. Temp right here. That's on the side here.
Yeah?
So, I mean, that is blistering hot. Like, you're talking probably 2 or 3 degree burns if you're touching that barehanded.
Oh, wow. That's cool.
Yeah.
So now that you know how a single image is put on a disc, you can imagine in your mind how you might put an image like this with multiple foil colors on it at the same time. They created this machine that's proprietary. They don't want me to show it to you because they want to keep that a trade secret, but they can put all kinds of images on discs, and they can vary all the different colors of foil. So one of the things that Brad and Chad kept talking about is they really like the idea of having multicolored discs with multiple colors of foil on it. So you can almost infinitely vary the possibilities of what an MVP disc might look like, and that's through all the different color combinations. So at this point, you have a beautiful disc that could be any number of colors, and it's got a really cool design on it that's got a very colored pattern. So they put them in boxes, they wrap them up with this really cool plastic wrap pallet machine, and then it goes to the warehouse where it's being prepared for shipping. And oh my goodness, do they have a huge warehouse. Look at this. It's incredible. They have all different kinds of things here. They were even testing out a new storage system when I was there that'll let them store 20% more inventory. Regardless, they ship this stuff out to retailers all over the world. In a second, I'm going to show you something amazing, but right now, I want to tell you about the second channel video because there are parts of the process I didn't show you in this video, and I think you'd be really interested in it. For example, how they recycle the pieces of plastic they don't use. They have this really interesting process that they go through. I find it to be hilarious. You're going to have to see my reaction to that over on the second channel, but it's amazing. They regrind this stuff. They're even trying to recycle the dust, which is awesome. That video also goes into the quality control of the plastic and how they measure these things geometrically correctly to make sure that they have the correct leading edge, it's fascinating. So be looking for that video over on the second channel. But for now, I interacted with Brian, who's the guy that programs the robots. And I asked Brad and Chad, like, hey, can I just have some of Brian's time? Because I want to put a camera on the robots so I can see this process from the robot perspective. And the results are fascinating.
吾有因头悬是曹何故？吾有因四毒师法何故？吾有因诸色往往何故？吾有因慈悲颠倒何故？林隐释然何故？木生如烟，雾长雷电，击背而歌，真意。
I thought that was awesome, but what I'm about to show you might be even awesomer. They're awesomer? Yeah, awesomer. There's a thing that happened in the disc golf world that was a moment. Like, this thing happened, and it changed MVP disc sports business forever. And I really think it's fun to watch Brad and Chad tell the story, because you can tell they genuinely get excited. Check this out.
We like to have that extra capacity, ability to ramp up quickly. Because disc golf, you can have those moments, those explosive moments where you better ramp up really quickly.
Why?
The example that we went through, 2021, James Conrad shot out, hit the greatest shot in disc golf history. It was the final hole.
You'll have to put the clip in your video.
Definitely got to get the clip in.
Okay, tell me about it. What?
So, Paul Macbeth and James Conrad kind of neck and neck on day 5 of the World Championship, 5-day event, and he was behind by 1 stroke. And on this particular hole, it was a situation where he had to make a shot 250 feet out to tie. And he just had to make it. And everybody knew, based on the circumstances, he had to make it. And so he ran it, and he just absolutely nailed it 250 feet away.
Really?
He tied the round, and then he went on to the playoff hole, and then he won that particular hole for the World Championship.
A lot of space out there to the left to see how aggressive of an angle he puts on this, or if he keeps it more neutral and just lets the disc drag over.
He's using that envy again, so it's a putter.
So when that moment happened, we had to ramp up super quickly to meet that demand. And so that's actually why we bought these 7 machines in this section here, because we just needed to ramp up as quickly
So
as
that
possible.
one shot in his world championship was this section of machines right there.
What? What? People just started loving disc golf because of that?
Well, it's just such a memorable moment in disc golf that there was just the demand for that particular product in that particular era.
Oh, he hit it with one of your discs.
Yes.
He just recently switched to our brand, and it was his first year playing with us, and he wins world in a spectacular way.
World champion.
That footage is from the Professional Disc Golf Association. Yes, there is a Professional Disc Golf Association, and they have this sweet logo that I love. It's from a documentary they did called The Holy Shot. It's a fun watch. You might want to check it out. When I showed my mom that shot, it blew her mind. A 250-foot putt, and just like the energy of the moment, it's very exciting, and I loved it. So I want to say thank you to MVP Disc Sports for inviting me up to check out the manufacturing process. I thought it was amazing, and I hope you enjoyed this video. We're going to do more videos with MVP. We just have to figure out what the topic's going to be. So thank you to MVP, Brad and Chad, for sponsoring this episode of Smarter Every Day. There's no...
Should be fine.
有生就有道，有高山就有深渊，有天地悬殊就有腥风血雨。我逃不掉，你也逃不掉。
弥陀二郎心法，我大圣根器，还有师傅的脑袋，就为在这黄风谷底一时快活。
阿弥陀佛，小施主，老衲乃是小须弥山之主，法号灵吉，也是这鼠妖的看管之人。大圣陨后，六根不灭，散落到了世间。这贼鼠私下寻得其中一根，因自身修为有限，难以炼化，于是生了歹心。我不慎中了他暗算，连头颅也被他一并割去，做了存放根器、修炼邪法的容器，连带黄风岭再次生灵涂炭，我之罪也。此番重回大道，全赖施主智勇无双，这世上应只有施主一人有资格保全此物。来吧，替我收好它。
上，烈日当下了。周经一贯来
人也，兽也，佛也，妖也。众生自有根器，持优劣为次第，可乱来不得。你说对吗，孙悟空？
你风沙里走了这一遭，